Yep, comes on everyone. Hope everyone revised the notes. So going ahead with the same thing. So if you take the same chart distribution, let's say this Q1 is here, and this Q2 is here. Now because of this Q2, you will be inducing charges on the surface here, which is minus Q, and you'll be inducing charges here. So this is plus Q. And if you see every line that comes here will be entering perpendicularly. And every line here will be leaving perpendicularly. So again, if you observe something here, the Q2 and these induced charges together do not have any field lines inside. You're getting it? So here the plus Q2 and its induced charges minus Q plus Q together. You're getting it? This word is important. Together. Do not interact with anything inside. Meaning for the inside charges, it behaves as if these things don't exist only. Getting it? So force between Q1 and Q2 plus force between Q1 minus Q and this plus Q total is 0. So this phenomena is called shielding effect. Means if you start moving the charge Q1 inside, that is not going to affect any charge distribution outside. Vice versa, if you move Q2 outside, that is not going to affect anything that is happening inside. Clear? This is what we proved last time. Now, the thing is that, if I ask you this question, is Q2 and Q1 interacting? Yes, there is a force between them. Is this minus Q attracting? Yes, it is attracting. Is this plus Q repelling? Yes, it is repelling. But these three together will always cancel out. Clear, everyone? Let's see our question based on this. Let's see a question. We have a spherical conductor. There is a charge Q2 here. There is a charge Q1 here, not in the center. the distance between them is some d. Hmm. Let's say this force is, yeah, so I think can I add something here? Okay, and this distance b, d, and this distance be z. Find force on Q2. Find the net force on Q2. Find force on Q1 due to charges on the surface of the conductor. Let's get this thing. This is a spherical conductor with a cavity, a solid. Think for a minute, then I'll show you the charge distribution. Then we will see. Let me add here on the outer surface of the conductor. Because if it's a surface, you might think inner or outer. Z is the distance between the center and Q2. Yes. Let's look at the charge distribution. I will just change the colors. Huh? So this Q1 here, this will induce a lot of negative here. It's a non-uniform distribution. And this will be minus here. And this will be how much? Minus Q1. We proved last time. If you put a charge inside a conductor, it will always induce equal and opposite charge. Now this minus Q1, it comes to the surface, you will get a uniform charge distribution. Right? Actually, now let's just say find the charges. We'll not be able to calculate charges on Q1 due to the conductor. Just let's write it down like this. That's better. Okay. So remember, so this is uniform distribution. Now, whether a distribution will be uniform or non-uniform will depend on what kind of surface it is. This is a uniform charge distribution. Whereas at minus q1 inside that inner surface of the cavity is non-uniform. Now, on top of this, this plus q2 will also induce some minus here and some plus here. So that would be minus q and that would be plus q. That means on the outer surface, actually you have uniform plus non-uniform. Make sense? That will make the whole outer surface non-uniform. So when I say conductor, how many charge distributions are there? So when we say conductor, try to understand. There is this uniform q1 is there. I'm just separating them out. Then you have this non-uniform minus q, and this guy is there. And we also have this non-uniform minus q1 is there. That's it. This is the meaning of conductor, outer surface plus inner surface. So you are trying to find the force between these three charge distributions and q2, isn't it? I'm trying to find between q2 or q1, between q1. Okay, q1 is inside. Fair enough. So now look at this thing. So where is q1 here? Q1 is somewhere here. This is a uniform charge shell. What is the field inside the shell? Zero. So what is the interaction between them? Zero. So due to that q1, which was uniformly distributed, that will create a zero field because it's like a hollow shell. E0, that's a hollow shell. Second, this guy, what about this guy? The plus q and minus q. How do we calculate this one? Now, if you remember, the force between q1 and q2 plus force due to this induced charges q minus q and q1 is zero, isn't it? This shell plus this q2 charge together will not interact with anyone inside. Is that making sense, everyone? That means these two charges will give how much force? They will give a force of k q1 q2 by d square, right? And if you see q1 q2 are repelling, so to cancel this force should have been this way. This would be towards q2. You cannot find this plus q and minus q directly. We have to use this argument that q2 and these two induced charges together are not going to interact with q1. Therefore, the induced charges of force should be equal to the force between q1 and q2 in the opposite direction. Agreed? Any doubts on this argument, please ask me. So in the previous thing, which asked you the question, right? Find the force due to the outer surface. This would have been the answer, discussion closed. But I included full conductor. Now the problem is, this we cannot find. Because that minus q is a non-uniform distribution, you cannot find force due to that on q1. So if the question was only outer surface, we can find. If you ask due to the conductor, we cannot find. Is this clear, everyone? Z is a distance between center and sphere. Yes. That has nothing to do with this, actually. Z would be useful if you want the force on q2. Can you tell me what will be the force on q2? Due to the conductor. Same thing, if you try to find force on q2, this is how it looks. Now we are finding force on q2, which is outside. Now for this guy, the q2 is outside. So this will give a force of k q1 q2 by z square. Agreed? Force on q2 due to conductor. This we cannot find. This will be again the same argument. Q1 and minus Q1 together will not interact. The force between Q1 and Q2 plus force between that Q2 and minus Q1 is 0. Therefore, this force should be K Q1 Q2 by D square towards Q1. This is the force on Q2. Is this making sense, everyone? So whenever you say conductor, there are actually three charge distributions. One on the surface, you have uniform or non-uniform, and inside the cavity, you have a non-uniform. All clear with this? Saina, clear with this? कुछ बोलो ना.
So the first case था जिसमें प्लस Q1 इंड्यूस किया था हमने सरफेस पे.
Yeah.
Then we said कि क्योंकि इलेक्ट्रिक फील्ड इनसाइड जीरो है इसलिए like उसका कोई इफेक्ट नहीं पड़ेगा ऑन Q1.
Right.
So even in the second case like इलेक्ट्रिक फील्ड तो अंदर जीरो है ना, तो like जो प्लस Q1 माइनस Q जो इंड्यूस हुआ है उसका इफेक्ट ऑन
Yeah.
प्लस Q1 जीरो नहीं होना चाहिए because electric field inside zero है.
No. On whom? Q1 and
On Q1.
this Q1 on this Q1 you're saying?
So inside on Q1 पे like जो प्लस
You're
Q1
saying
माइनस Q जो इंड्यूस हुआ था उसका इफेक्ट ऑन प्लस
yeah.
Q1.
You're saying these two, the red ones or the
Yes
green
sir.
ones?
So the red ones.
So you're saying these two ka charges on whom? This guy?
Yes.
Why?
Suppose
This
inside electric
guy,
zero है.
this guy, and this guy, all these three together is zero inside. Who created minus Q and plus Q? Who created these induced charges?
Plus Q2.
Plus Q2. These field lines are getting blocked, right?
Hmm.
So these three together will not create any field inside. Nay, again, when you say field is zero, okay, field is zero due to whom? Is the field zero only due to minus Q?
No, all three.
Is field due to zero only plus Q? Actually, if you see, both of them will add up in the same direction.
Hmm.
This guy ka field is countering them, so total three of them are cancelling out. Make sense?
Yes sir.
Why can't we use FQ1, Q2? I know you can just speak out, right?
I mean, if we can find FQ1, Q2 on Q1 with this.
No. Again, when there are a lot of Q1s and Q2s, point charge distribution, which one are you talking about?
If the charge inside Q1.
Inside ka Q1 charge.
In the previous question, we found FQ1, Q2 by using the FQ1, Q. Yeah, there's KQ1.
That is only.
Yeah, KQ1, Q2 by D square.
Yeah, that is between what? That is the force between the 2 point charges.
So why can't we Newton's third law it and
Newton's third law will give you what? If Q1 is pushing Q2 with F, Q2 will push Q1 with F. उसमें क्या है Newton's third law? What is your system here? You're taking Q1, Q2, right?
Right.
What is Newton's third law? If Q1 is pushing Q2 with F, Q2 will push Q1 with F, so that is fine. You want to apply third law between whom?
I want to know why we can't use FQ1, Q2, the equation you've written on top to find
Right.
To find the force between Q2
Between
and the induced charges.
this minus Q1?
No, the small q's.
These charges, are they equidistant?
No.
Do you know the magnitude?
No.
How will you find them?
Right, okay.
And this K1, Q2, Q2 by D square is the force between whom? That is the force between Q2 and this Q1.
Right.
How are you relating that force between these two and these two?
Okay, yeah, got it.
Getting it? That small. If you ask me now, sir, can you find the force due to small q and minus q? See, I can't find now. If यही हुआ ना देखो, I can't find the force due to these two guys on Q2. We cannot find that because it's non-uniform distribution. I cannot do anything about it. Like I don't know the magnitude, I don't know the distribution, I don't know anything. Clear? All clear with this?
So
Kush.
Sir, in the second case, when we are finding the force on Q2,
हाँ
like in that case, हम लोग जो minus Q1 से जो force हो रहा है हम उसको consider कर पा रहे हैं, but like उसमें भी तो वो
that
non
is
uniformly distribute हो रहा है.
that is again, see, look at the logic. These together will not interact with anyone outside.
Yes, sir.
So if I know the force between Q1 and Q2, that should be the force by the minus Q1 in the opposite direction.
Oh, right, yeah, okay.
You're getting, see, the story is always like this. You're saying A plus B together will not, it's like A plus B together are completely vanishing.
Yes,
If you only ask me, does Q2 know there's a Q1? Yes, it knows. Does Q2 know there is a minus Q1? Yes, it knows. Does Q2 know that both of them exist? It doesn't know. The moment you say Q2 and its induced charge, game gets over there. They behave as if they don't exist. You're getting it? So from that we are arguing. Therefore, the induced charges must give equal force. I hope everyone is getting that. Clear? Like this is the problem with the chapter. It's like all verbal agreements only. There is nothing like a solid numericals or something. Let's see next one. Next one is even better. If you got it, I think you will understand this charges and stuff. But this one is a pretty good question. So we have a conductor with a cavity. O is the center of sphere. This is O dash center of the cavity. So there's a charge Q1. Here there is a point A. Here there is a point B. And in the center exactly, you kept a charge plus Q2. So there are two charges here. Q1 outside and Q2 at center. So from O to B, the distance is Y. O to A dash, the distance is small r. O to Q1, the distance is D. Q1 to A, the distance is Z. Maybe I'll put them in green. Q1, Q2. So O dash is center of cavity. This sphere cut distance is R. R is the radius of cavity. A is a point on the cavity. B is inside the cavity. Q1 is outside, Q2 is at the center. Now, first question. Find the potential at O, A, B. Find potential at A only due to conductor. Be careful, potential, huh? It's not forces or fields. The charges outside do not create any field inside, but they can create potentials. Get this done. This should be a pretty good advanced paragraph question. Do think about this. I know you understood, but I know you're also confused a bit. So the best way is ask your questions, whatever you think. argue, things will get sorted. That is the best way to do. If you just keep wondering, it won't happen. Whatever you think is confused, ask. Not today, ask me next class. Figure it out. Ishan.
The distance between O dash should be given now.
Distance between O dash
And O.
Nadia.
Okay.
You don't need it. If you think you need it, ले लेना O dash. देखते बाद में.
हाँ ये सर नहीं चाहिए सर.
Try everyone. K, Q1, Q2, Z square, R square. What are you doing, Aryan? I asked you potential record. Potential. K, Q by R होता है potential का dimensions. You got K, Q1, Q2 by R square types. Think. Take 2 minutes. Try to draw the. First of all, I tell you, draw the chart distribution. Don't be in a hurry. Put a chart distribution properly, plus, minus. The way I showed you the previous one, देखा कितना detail, like, this is uniform, this is non-uniform. Put it detail. That will be better. Directly found potential at A only. That is wrong. Try. KQ2 by R, KQ1 by D. देखने तो मुझे आंसर याद नहीं है actually. Now, if you see the distributions, so that Q2, first let's talk about that Q2 here. Q2 is at the center. So this will create a uniform charge distribution. So whether you're uniform or non-uniform completely depends on the shape and where you keep the charge. So this guy will create a minus Q2 and the same guy will come onto the surface and outside is also uniform. And that will be another Q2. Now this guy who is outside, Q1, will create a non-uniform distribution minus Q and plus Q. This is your O, this was your A, this somewhere B was here. This distance was D. Okay, first let's talk about O. Now, when you say potential at O, let's see how many potentials are there. So again, when you say potential, see here I just said potential at O, A, B. That means you have to find potential due to everyone that is present. I hope you're getting the meaning of it. The second question is specifically mentioned only due to conductor. If I say potential, it is everywhere. So potential due to this Q1, potential due to this Q and minus Q on the surface, potential due to that Q2, which is uniform distribution on surface, and potential due to this Q2, and potential due to the minus Q2, which is induced. Agreed? Now, if you look at each value there, this guy would be k q1 by d. Potential is scalar. So you can just directly add it up. These guys are 0. Why? Even though charge distribution is non-uniform, everyone is equidistant from the center, isn't it? How much ever plus you have so much same negative value. So the total is 0. So the reason is they are equidistant from the center. So center is actually special, or else this q1 minus q will mess up everything. q2 on the surface, it's the potential, it's a shell. So kq2 by the radius capital R. q2 will be kq2 by oo dash, and this guy would be minus kq2 by oo dash. Luckily, it is uniform. Even if it is non-uniform, you could have confidently said this would be 0. Because the q2 and minus q2 will not interact with anyone outside. Getting it? So that means they create a 0 field outside. So infinity at potential is 0. So field is 0. So potential at O is 0. So basically q2 and minus q2 will not create any potential at point O, even if it is non-uniform distribution.
Can you repeat the reason?
देखो ना, q2 or minus q2 का, there's not a single field line outside, agreed?
Yes, sir.
So there's no field outside, there's no potential difference. There's no potential difference from where to where? From O to infinity. What is the potential at infinity? 0. So what is the potential at O? 0. Only due to these two charges. Clear, everyone? So potential at O will be k q1 by d. Hareshan, you're right. Plus k q2 by r. Now VA is equal to VO. Why? It's a conductor, isn't it? Conductor is equipotential. O and A are in the conductor. So A के लिए अलग से calculate करने का जरूरत नहीं था. Conductor is equipotential. If you take any 2 points on the conductor, the potential should be same. And I already calculated for O, so they should be same. Make sense? B का क्या करेंगे? B is a good one. Think I'll give you a minute. Any doubts on these two? Please ask me. VO and VA. Arjun, Aryan, clear now?
Yes, sir.
Ali, Aditya, got this? Anika? No, Ishan, don't get confused. Shielding is only for field. If you're shielded, potential 0. Potential बोल रहा, field 0. मतलब potential difference 0. Potential difference is 0. Let's talk about that cavity here. See, if you look at that cavity here, this is Q2. This is minus Q2. That is anyway uniform, so field is 0. So at a distance here, let's say some x, the field will be how much? K Q2 by x square, agreed? This is the field inside the cavity. Think about it, meaning inside the cavity, the only people who can create field is minus Q2 and plus Q2. Minus Q2 is uniform shell, so field is 0. So the field inside cavity is k q2 by x square. Point B is somewhere here. A is somewhere here. It doesn't matter. Everything is a conductor only. So potential difference you want VB. So VB minus VA is minus integral E dot dr. Remember this? So here the limits will be y to small r. So minus potential is minus k q2 by x square. Or you can just small r already radius liya na, into dx. Limits will go from r to y. This is VB minus VA. So potential at B will be VA, which I already calculated in the previous one. And this guy would be KQ2 minus 1 by X limits will go from R to Y. So this would be VA plus KQ2 1 by Y minus 1 by R. That's your answer. You cannot find it B in any other way. Biggest problem kya hoga? At point B, these charges are there. These are the biggest goof ups actually. This is not uniform distribution, no? They're not equidistant. I cannot calculate due to those two cases will mess up if I go outside. So I have to somehow see it from the inside only. Luckily, inside the field is uniform. And I already know the potential on the surface. If I know the field, if I know the potential at A, I can find B using VB minus VA integral. Have a look at this. This is what makes this question pretty good.
सर एक क्वेश्चन है
बोलो ना.
the Q1 जो outside है it will induce some charge on the out of the sphere now.
These guys, na?
So will हाँ sir, and will that induce any charge inside the cavity?
अरे story तो वही है ना God. These three guys will not interfere with anyone inside. वो three cancel हो गया. If you ask me, only these two will do something. Yes. You getting it? Only these two will do something. Yes. So I'll bring this guy and I'll cancel everything.
Yes,
Because I don't know what to do with that plus Q and minus Q. Say what to do. I have no idea. You need the third guy. Let him kill everyone and done discussion there. Can you explain why field of minus Q2 is 0? Because minus Q2 is a uniform distribution. This minus Q2 here is like what is the field inside a hollow shell? 0, right? It's a uniform distribution because Q2 को अपने center में रखा था. If you had not kept Q2 at the center, then the game would have been gone. Matlab, you couldn't have done this. If this Q2 was not in the center, this field you can't calculate. वो छोड़ दो. Even if you can calculate, this will be non-uniform. That won't be 0. Just because you kept it at the center, it became easy. I hope everyone is clear with this.
How did you not take the potential due to the other three charges?
Why didn't I take? I took no. मतलब VA आया कहाँ से? VA तो came from there only.
No, but
My argument is this. Potential difference between these 2 points is field into dx between these 2 points. Agreed?
Oh, okay, right. Got it. Yeah.
I am not even going outside because the moment I go outside, things are weird. Let's not get there. So we took the field from inside only.
Yeah, got it.
Clear, everyone? Making sense? Saina, Utsa, clear with this? Yasha, Udayan,
I
Neil?
know we're not talking about the people outside, but
Hmm.
does that mean that the potential created by all three outside
It's not
cancel
0.
each other?
No, potentials cancel नहीं होगा. देखो, that was an argument actually. Now see, listen everyone. ये जो minus Q plus Q, again be careful here, and this plus Q2, these together create field 0 inside. Agreed? Inside, outside nahi hai. Outside is not 0. Fair enough? That means these three ka potential from here to here, they'll have same potential difference, isn't it? So what is the potential at the center? So that means potential at infinity is 0. Because there is a field here, this won't be 0, isn't it? They don't cancel out. Right, Saina?
Yeah.
So the potential here will be how much? K Q2 by something, potential at the center. So from here to here, field is 0. So these three charges together create a potential of V0. Fields will cancel. Potentials, there is some constant. Isn't that the meaning of it? If field is 0, what is potential? Constant, na? E is minus dV by dr. V is not 0. Getting it? That constant can sometimes be 0 for a special case. I hope that answers. Right? Field is 0. If field is 0, potential is not 0. There is still one more question, everyone. Potential at A only due to conductor. इसका क्या करना है? Only due to conductor. minus K2 by R. Okay, let's see. Now let's look at A ka guy here, okay? This is the same story, isn't it? So when if you want potential at A, this is the potential due to everyone, is agreed? This is the potential due to everyone. In this, who is the conductor? This is a conductor. This is a conductor. This is a conductor. Agreed? Make sense? This is the potential at A due to everyone. This is potential at A due to all charge distributions. Whose value I know? In this guy, this guy, and this guy are actually, they are the conductor. Means I want to find the potential due to these three people only. Agreed? Now A is somewhere here. This distance is Z. So VA, you're done actually. हो जाएगा. So VQ2, yeah. So how much is this? So VA, which I know, what is potential due to Q1 at point A? KQ1 by Z plus, that is a potential due to conductor. I'll just write it down like this. Plus that V minus Q2. Q2 का potential at point A is KQ2 by R. Is this making sense? So if I shift everything that side, the potential due to the conductor will be VA minus KQ1 by Z minus KQ2 by R. And what is VA ka value? VA is same as V naught, KQ1 by D and KQ2 by R. I hope you're getting it. I'm not even trying to calculate them individually. I know potential at A is due to 1, 2, 3, 4, 5 charges. Among these 5 charges, 3 of them are the surface. So these two guys and these three together is called a surface, the conductor. I know how to find due to Q1. I know how to find due to Q2. Shift them that side, you'll get the answer from a conductor. And Q2 ka charges, this distance is smaller. So KQ2 by R. This distance is Z, KQ1 by Z. That's the reason Z is given. How did it become equal to VA? What did it become equal to VA? Which one, Aaron? We didn't consider VQ1, VQ2. I didn't understand. Can you just unmute and ask?
Sir, how is it equal to V? Like VQ1 and VQ2, though we didn't consider, na?
I was saying like this thing. See now, ये सब छोड़ दो. Potential at A is equal to potential due to Q1 at A, potential due to this at A, potential due to this at A, potential due to this, and potential due to this. Agreed?
Yes.
Which should give me this value, which I already know.
Hmm.
ये तो total potential था.
Yes.
Right? Now in this, what is a conductor? Conductor may you have this charge, and this charge.
Yes.
So you're asking me to find the sum of these three charges, right? Sum of these three potentials. Now, if I can find this, and if I shift them both on the other side, won't I get these three ka potential sum? Isn't that what you're asking? Find the potential at A only due to the conductor.
Yeah.
You're getting it. I know total due to everyone, conductor, outside, inside, sub milake. Getting it? So if I can
But-
remove those two guys, which are not the conductor, then what's left should be the conductor. Is that making sense, everyone?
Yes, I got.
Rehan, Lakshika, clear with this? Swastika, Maulika, clear? Sure? Ishan, Kush, clear with this?
Yes, okay.
Great. It's a good one. So again, I'm telling you, these two questions especially, right? Try it again. See the question, try to do it on your own. Getting it, you have to get used to this. It's a good one. This is how they will frame questions on this. Next thing. Earthing. So what is earthing? So when a conductor is connected to the earth, its potential becomes equal to the potential of the earth. Basically, that's all. Like when you conduct two metals or something, we take the potential becomes same. So earth ka potential is actually slightly negative. But for convenience, since you're measuring everything with respect to earth, you can choose anything as zero reference. For convenience, we choose potential of the earth as zero. Technically speaking, earth ka potential is actually slightly negative. So this is the symbol for earthing. So whenever you connect something to earth, this is the symbol. So especially when you earth, you need to remember two things. One, potential becomes zero. Second, charge is not conserved. Because the charge can flow in and out of the earth. Any system that is earth, charge is not conserved. Because you can get some charge from earth or some charge might have gone to the earth. Charge is not conserved on the system which is earth. So these are the main two things. The potential becomes zero and the charge is not, charge is not conserved. It is slightly negative. Matlab, the earth ka charge is like that only. If you see these lightning bolts and everything, right, there's a positive discharge from the atmosphere to the earth. So that is this people measured it somehow, it is slightly negative. There's no particular reason as such. Clear with this? Now let's see a question. We have a shell and we have a shell, concentric shells. This charge is minus 2q, radius is r. This charge is 3q. We have a switch between them. Let's call it S1. Let's do one at a time. Okay. Find the charge distribution before and after closing the switch.
So what is the radius of the bigger sphere?
2r ले लेना. These are concentric conducting shells. In these questions, there's also something called heat produced. We will do that in capacitors. That would be a much better way to do there. Here, if we do heat produce, we have to find self energies and interaction energies. It becomes a big mess. But capacitance will get the answer in a step line. Let me help you with this first one. See, if both are open, this is how the charge distributes, everyone. So what is the charge inside? Minus 2q. Now understand, this is minus 2q. I showed this in the beginning, case 1. If you put a charge on a surface, there will be no charge inside the cavity. I agree, it's a very thin shell, but try to understand, even though it is a thin shell, it is still a metal, isn't it? This is a metal. So end of the day, that big cavity, it's like a cavity inside. So if you give some charge here, minus 2q, it will remain on the surface. There is no charge inside. Getting it? So inner shell ka inner surface has 0 charge. Outside is minus 2q. Now, if the charge is minus 2q, it will induce always equal and opposite charge plus 2q. That we proved, right? If you put a charge on q, the cavity will be 2q. Now, if this is 2q, since the total charge should be neutral, the total charge should be conserved. What is the charge outside? 3q. So this has to be plus q. Have a look at this. The inside charge, this is before closing the switch. Anyone has a doubt on this distribution, please ask. There will be no charge on the inner surface of the inner cavity. That means all the charge minus 2q should be on the outer surface of the inner shell. If this is minus 2q, this should be plus 2q. If you're still confused why that should be equal, think about like this. Consider a Gaussian surface passing through this thin outer shell. Since it is passing through conductor, field is 0. Field is 0, charge enclosed is 0 because flux is 0. I hope you remember that argument. Gaussian surface through the conductor of the outer shell. E0, flux is 0. Therefore, Q enclosed is 0. So you should always induce equal and opposite charge. So if this is plus 2q, to balance the total charge on the outer shell, which is 3q, there should be plus q on the outside. I hope that is clear, everyone. Now, if you close the switch, what happens? The moment you close the switch, look at the charge distribution. Let this be small q. I don't know how much is there. This is minus q. This should be x. The total charge on the shell should be constant. The total charge on the shell was 3q minus 2q, which was q. So this should be equal to q minus q plus x. So therefore, x is equal to q. There we found out the value x is equal to q. Great. Now you tell me, whenever you connect two shells with a connecting wire, what happens? The potential becomes same because they're a conductor. So potential at A is equal to potential at B. Now be careful here. It's easy there. You should know how to just calculate potential due to shells. Now how many charge distributions are there? 1, 2, 3. So you need to just ask yourself, where is this point A, inside or outside? Listening? For this small charge q, where is this point A? On the surface. For minus q, where is the point? Inside. For plus q, inside. So apply the potential formula due to shell. Kq by r, this is due to the inner shell, minus kq by 2r due to the minus q, plus kq by 2r. Actually, I could have taken these two together because the distance is same, but I'll keep it separate so that you will get it. Now, potential at B. For this charge, it is outside. For this charge, it is on the surface. For this charge, it is on the surface. That's a straightforward formula for potential of a shell. Kq by 2r minus kq by 2r plus kq by 2r. This guy gone. This guy gone. You are left with kq by 2r is 0. Therefore, q is equal to 0. This is how we prove it. Please have a look at this method. Quite a useful one. This is how we solve initial questions. Luckily, in this question, there's a faster way to get the answer. But first, let's get this thing properly. I hope everyone understood. Because you connected them, the potential at A and B should be same. Due to whom? The potential at A due to all charges should be equal to potential to all charges at B. Now, there's a faster way to argue this. If there is a Q here, that means there are field lines from here to here. Agreed? This will help you in the exam. If plus Q is not 0, there are field lines. Between inner and outer shell. And we know if there is a field, the potential decreases. Therefore, potential should change. Right? But VA is equal to VB, that means potential is same. Therefore, there's only one possibility. Therefore, the field has to be 0. Implies Q has to be 0. No, concentric shells need not be equipotential. I'll show you next one. You can create a situation where they're not equipotential. We'll do that as the next one. But are you getting this argument here? If there was a charge, there would have been field lines. If there were field lines, then there's a potential difference between this and this. Because in the direction of the field, potential decreases. So you are saying A and B will have different potential. But that is not possible because both are connected by wire. They should have same potential. Therefore, your argument that Q is not equal to 0 must be wrong. Therefore, Q has to be 0. Is that making sense? Without doing any calculations, you could argue that much. Any doubts on this page? Please ask me. Kush, convinced? Saina, convinced with that argument?
No, but in electrostatics, we defined that concentric shells were equipotential. So shouldn't the
When,
charge...
where did you learn that? I didn't teach you anything like that. Did I teach you something like that? At least I didn't teach anything like that. So I don't know where you learned that, but I have no idea. So if it is some new physics concept, then you should apply for a Nobel Prize. At least on Earth, it doesn't work that way. Let's see the next question. You'll understand. That was true. Getting it? That is true in certain cases, right? But problem kya hai na? You'll remember like that, you'll get trapped. Look at the same question. This was minus 2Q. This was 3Q. This is a switch and this is grounded.
Inner
Same
shell is
question.
grounded.
Inner shell is grounded. Find the charge distribution of the inner shell is grounded. Saina, do you still think it will be equal now? This is what I was saying. Because the inner shell ka potential becomes 0, outer shell is not 0. Let's get this. Let's see. So this guy is grounded. Now see the problem. The moment you ground something, I don't know the charge. That is the first thing. Put a variable. Forget about whatever is the charge inside. I don't care. So this is Q. This has to be minus Q. That we proved already. Now the total charge on the outside should be constant. So this should be 3Q plus Q. This is the charge distribution. If you earth something, charge is gone. Forget about it. Put a variable X or Q, Y, whatever you want to call it. Then this point here, potential at A is 0. Due to whom? Due to everyone. So K Q by R minus K Q by 2R, that minus Q charge. K 3Q plus Q by 2R would be 0. Q by 2, 3Q by 2 plus Q by 2 is equal to 0. So Q is equal to minus 3Q by 2. There, that's your charge distribution. This total has to be how much, God? Outer shell में कितना charge था? 3Q. That has to be conserved, na? You're not touching the outer shell. Are you getting it? The outer shell ka charge has to be conserved. Inner shell ka charge is messed up. Make sense, everyone? So be careful. If you're grounding something, 0 nahi hoga har baar. 0, when it'll happen, that's a case. If you ground the outer shell, then this will become 0. So don't blindly remember things. Be careful with that. Clear, everyone? Got this? I think if you got the next one, we can say you got the shells clearly. Shell, shell, shell. So here you have a small hole. This is S1. This is S2. So this charge is plus Q, radius R. This charge is minus 2Q, radius 2R. This charge is 3Q, radius 3R. 3 concentric shells. There is a hole in the middle. So there's a wire passing from 1 to 3. It is not touching shell 2. And the shell 2 is grounded. Find the charge distribution when both the switches are closed. There. This is everything. 3 shells, connecting wire, grounding, sub dal diya isme. Try, I'll give 3-4 minutes. Find charge distribution when S1, S2 both are closed. If it's a matrix matching question, right, they can play around. S1 is closed, find the charge on the inner shell. Now S2 is closed, S1 is open. You can play around like that. But that is fine. If you close both of them, you'll get everything. Anyone not convinced with anything here, please ask. Others do keep your cams on. There are 5 surfaces, right, Shan? Inner shell ka
You will want
outer.
for all the surfaces.
Each
Okay.
surface, each surface.
अच्छा, fine, sir.
वो better है ना? Instead of finding full, finding each surface is more this thing. You have more data. Q minus 2, Q2, Q minus 4, Q. For some reason, I'm really doubtful that is right. I was not expecting a good answer at all. R2, R3, R, it is so goofed up. Getting such good numbers looks difficult. Let me show you the distribution. Let's see how many of you got the distribution right. Meaning, assuming the variables initially. First thing, try to understand what is the charge inside. I don't know. Let it be Q. Why you don't know? Because the inside and outside connected, some charge can flow outside, isn't it? Is there any guarantee the charge will stay inside? No, we don't know. So some charge could have gone outside to the third shell, or some charge could have come from third to first shell. I have no idea. So let it be Q1. Then this also has to be minus Q1. Why? Equal and opposite charges. What about the second shell? I don't know. Why? It is grounded. Charge is not conserved. Second variable. So the opposite has to be minus Q2. Outside, let it be X. Now, charge is conserved, but on whom? Charge on shell 1, that is the inner one, and shell 3, that is the outer shell, is conserved. That is Q plus 4Q. This 3 plus 3Q. This much I know. You can't say charge on 1 is constant. You can't say charge on 3 is constant. So what is this? So this is Q1 minus Q2 plus X. This na 1, 2, 3. This is the total charge on inner and the outer shell. This should be equal to 4Q. So X ka value is 4Q minus Q1 plus Q2. That's your charge on the outer
Why did you
surface.
take it एक साथ?
एक साथ मतलब? Because ये दोनों wire से connected है ना?
आपने connect कर दिया, ठीक है.
S1, S2 both are closed. Question वही है ना? After closing ना? Before opening कुछ है ही नहीं question. These are the variables, everyone. First check this out. Ask me if you're confused about these variables. So there are total 3 variables, Q1, Q2, X. X to nikal in terms of Q1, Q2. So we have 2 variables. I need 2 equations. So if I call this point A, if I call this point B, and if I call this point C. So we can clearly see VA should be equal to VC because they're connected by a wire. So what is the potential at A? K Q1 by R plus, I will take these two charges together because they're at the same distance. K minus Q1 and that Q2 by 2R. I will take these two together as one charge because both are at the same distance. K minus Q2 plus X by 3R. You can write them separately also. You'll get the same thing. This is the potential at A. Please ask anyone is confused with this. Because the point A is on the surface, so KQ1 by R. For Q2, this is inside, so KQ2 by radius. For X, it is inside, KQX by radius. This should be equal to K. Now we are talking about potential at C, KQ1 by 3R plus K minus Q1 plus Q2 by 3R plus K minus Q2 plus X by 3R. Luckily, this guy and this guy goes off. Esha, you did get something in 11th, might be right. Then, if you see this equation, this would be Q1 minus Q1 by 2 plus Q2 by 2, Q1 by 3 minus Q1 by 3 plus Q2 by 3. This guy goes off. Bring all Q1s together. Q1 by 2 is minus Q2 by 6. So I have Q1 is equal to minus Q2 by 3. That's one variable. Please check your equations. Clear? Then the second statement, potential at B should be equal to 0. Why? It is grounded. Now the potential at B for Q1, it is outside. So KQ1 by 2R minus plus K minus Q1 plus Q2 by 2R. It is on the surface. The outside guys will be minus Q2 plus X by 3R should be 0. Simplify this. So Q1 by 2 minus Q1 by 2, Q2 by 2 minus Q2 by 3 plus X by 3 is 0. This guy goes off. And this will be Q2 by 6 is minus X by 3. So Q2 is minus 2X. Clear? And how much is this thing? Minus 2, 4Q minus Q1 plus Q2. Let's eliminate Q1. So take this Q1 from here and dump it here. You will end up with Q2 is minus 8Q minus plus 2Q1. That would be minus Q2 by 3 minus 2Q2. So Q2 minus 8Q minus 2Q2 by 3 minus 2Q2. Bring all Q2s to one side. How much is that? 3Q2, 3 plus 2 by 3, 3, 9. Yeah, 11 Q2 by 3 is minus 8Q. Q2 will be minus 24Q by 11. I might have goofed up the calculations, but do check it out. Main thing is this equation, VA is equal to VC and VB is equal to 0. Got the same, Yasha? Yeah. So there, I am right. Yasha got it right. This is how you do this. So Q1, Q2, Q3. So Q1, Q2 आ गया तो Q1 भी आ जाएगा. Right. Also got the same answer. Is this clear, everyone? This is what I said. I didn't feel answers will be good. So VA is VC. Most people go for the distribution only. You don't know the charge on the inner surface. You don't know the charge on the second shell because it is grounded. The whole charge distribution is messed up. VA is equal to VC and VB is equal to 0. These are the only two data points you have. And charge 1 plus 3 is constant. Clear, everyone? Understood? You can handle 3 shells, you'll be able to handle. Kush.
So for the second shell, जब हमने अर्थ किया था तो उससे second shell की inner surface को affect नहीं करेगा.
Argument is this: if this is Q1, this has to be minus Q1.
But वो अर्थ है, like हमने उसको अर्थ किया था ना, तो like
No, Kush. If you earth something, what happens?
potential like 0 जाता है.
0. And charges? Not concerned. बस हो गया, इतना ही story था उसका, right? But we also proved if you have a charge Q1 here, it should induce minus Q1 here from Gauss law. You want to listen to the story? I'll tell you. Consider a Gaussian surface passing through the conductor of the second shell. Since it is passing through conductor, field is 0. Therefore, flux is 0. Therefore, charge enclosed is 0. Therefore, Q1 and minus Q1 total is 0. Happy?
Yes, sir.
But you said, na, sir, I wanted to hear the tape recorder recording. I would have started it. Usme kya hai? So the thing is, what you're saying is true. When you ground something, right, the metal in the middle, that's what is a shielding effect. Bahar to kuch bhi karo. Once you put a metal there, even though it is thin, inside charges don't get interfered. Clear with that? Take a break, everyone. Come back by 7. Any doubts so far? Please ask me. we did some pretty good questions today. So do make sure to go through them. They're good because less of a numericals and more of an argument. So that's what makes it good. Chalo, come back in 10 minutes. Bolo, Neil.
Sir, in the 17th question, you directly drew the diagram after connecting. So is there any need to draw the diagram before connecting?
nahi chahiye na. Question is what? After the switches are closed, na?
Okay.
So initial charges, we don't care what is it. Because once you close them, charge distribution to pura mess up hi hone wala hai.
Yes.
Yeah. Until unless they ask you, you don't require.
Okay, sir.
Utsa got something. Chalo, take a break. Come back in 10 minutes.
So
Yeah. Cams on, everyone. After VB0, won't it be KQ1 by R? अरे आर्यन पॉइंट भी कहाँ पे है? At a distance of 2R ना? Point B is outside, right? So KQ1 by R. हाँ कुछ
sir, in the 16th question, इसके पहले वाला,
हाँ
so like
A और B
the A1,
हाँ
like जब हम when we connect two shells, तो उनका potential same करते हैं ना?
सेम बस इतना ही
So-
था और कुछ आर्गुमेंट नहीं था
So like can we not do कि like minus 2q से हम x charge like we say कि minus 2q plus x and that becomes 3q minus x. Like ऐसा
I
नहीं
didn't
कर-
get you. You're saying let Q charge go outside ऐसा बोल रहे हो?
Yes.
हाँ कर सकते हो कुछ प्रॉब्लम नहीं एंड ऑफ द डे वही आएगा तुझे
So like
you'll get
उसमें
small q is equal to minus 2q
हाँ हाँ
हाँ
उसके लिए
obviously नरे god your small q and my small q are different
हाँ okay ठीक this confirm कर रहा like मेथड चाहिए ना I thought
हाँ
कुछ
right
आता नहीं
है
है
सेम ही है ना कुछ डिफरेंस नहीं है you're saying charge q is flowing I am saying something meant if you calculate you'll get the same thing see now
Yeah.
initially you had minus 2q now 0 मतलब कितना बाहर फ्लो किया minus 2q
yes sir
चलो everyone next one
Sir, can you show the 17th one?
हम्म
सर उसमें VB equal to 0 since अर्थ के नीचे KQ1/2R कैसे आया वो नहीं समझा
अरे तुझे भाई एक्सप्लेन कर रहा था मैं ये q1 to b का डिस्टेंस कितना था 2r ना
हाँ
तो इनर शेल का पोटेंशियल एट पॉइंट बी कितना था के क्यूब एट डिस्टेंस वेयर इज बी
अच्छा ओके ओके समझा
बी इज एट अ डिस्टेंस ऑफ 2r ना
सर तो फिर माइनस KQ मतलब जो थर्ड टर्म लिया उसमें 3R कैसे आया उसमें R आना
बिकॉज
चाहिए
ये शेल के लिए पॉइंट भी अंदर है ना रे गॉड के क्यूब है रेडियस इफ
हाँ
द पॉइंट
तो
इज इनसाइड द शेल आउटर शेल का रेडियस कितना था
आउटर शेल का रेडियस 3R था
सो व्हाट इज द पोटेंशियल इनसाइड के क्यूब है 3r
ओ अच्छा
यू जस्ट नीड टू सी दिस थिंग आर्यन तू जो भी शेल लो इज द पॉइंट आउटसाइड द शेल इज द पॉइंट इनसाइड द शेल
ओके
आउटसाइड द शेल के क्यूब है डिस्टेंस इनसाइड द शेल के क्यूब है रेडियस
यस
क्लियर so we have a conducting shell radius r this is a charge q traveling towards the shell with speed u this a here is ammeter so this can measure current in the circuit now for the information current I is nothing but dq by dt rate of change of charge find current in the circuit at this instant this question I could have asked in current electricity also okay so then keep your cams on others do keep your cams on How do we do this? As this is getting closer and closer, something happens, and there's a current flows through that wire. Find the current. Let the distance be x. Let the charge on the shell be q. I don't
Can
know.
you give 2 minutes to try the question?
You'll get 1 minute. Fast. Then you should bargain. It's a little more. Then I'll say 5 seconds more.
Fine, sir. 1 minute is fine.
इतना discussion में तेरा time हो जाएगा. Q R U by D square. Q R न्यूमरेटर में आया क्या अर्जुन?
Yes, sir.
Question here. हो सकता है. Let's see. So the catch here is, now understand one thing, there is no guarantee this is uniform. This is a non-uniform charge distribution. So if you look at the center, potential at the center is due to two charges, k q by x, which is pretty far, which is coming from distance x, and k q by capital R. This is the charge on the surface. Even though it is non-uniform, they all are equidistant from the center. This should be 0. Why? It's grounded. So in order to maintain zero potential on the shell, because of this charge, there is a positive potential. So you will get negative charge on the shell in order to make a zero potential. So charge q is given by minus q capital R by x. This is the charge on the shell as function of x. Now what is current? I is equal to dq by dt. So this is minus qr minus 1 by x square dx by dt. This thing is qr by x square. Be careful, dx by dt is minus u because x is decreasing. What is the meaning of minus sign? Current is not going into the shell. Current is actually flowing out of the shell. So this is the current as function of distance x. You can substitute d ka value. Negative indicates the direction I took is wrong. Kind of makes sense because इसमें negative charge आ रहा है, मतलब positive charge is flowing into the earth. Current is going into earth. Substitute x का place में d and you'll get the answer. Lon लेके आया God.
I wrote 1 by x का differentiation as ln x.
होता है. I can understand. It's like, the Avengers ka movie. After doing so much nonsense, Thanos simply dies with one cut. Itna hopeless hai wo. Easy? Got this? Easy question. Getting it. If you see, the steps are quite easy, but figuring out, okay, aisa ho raha hai, that is the most important thing. As this charge gets closer and closer, the induced charges become more and more. That means the shell is acquiring more and more charge. So the charge is flowing. That means there's a current. So this could be a good question in current electricity also. All clear with this? Any doubts? Anyone not convinced? And I hope they understood the meaning of minus sign. Next thing, charge distribution on parallel plates. Now we are slowly entering capacitors actually from here, but okay. So this would be the parallel plates is the end of Gauss law and the beginning of capacitors normally. So till now we took shells and all great, but what happens with parallel plates? So first thing, whenever we talk about parallel plates, we keep them very close. So we study only plates which are very close to each other. Reason, if D is very small, we can assume the field is almost uniform. When you say very small, try to understand D is very small compared to the dimensions of the plate. That is the meaning of small. Meaning if length of the plate is 1 meter, we are talking D is 1 millimeter. Parallel plates, the questions are straightforward actually. If you know the basic results, you'll get the answers. We can assume field is uniform. Basically, you can treat them as infinite plates. The problem, if the plates are, the distance is comparable, the edges start getting messed up. The field lengths would start going like this. This thing is called fringe effect. Fringes means the edges basically. The field on the edges is not uniform, so we don't want to deal with these kind of things. Have a look at this page. So we study only plates which are pretty close to each other. Clear, everyone? This is the same concept when we start capacitors. It is the same idea. Then we also keep the capacitors pretty close. Now, so now if you give charges to the plates, I want to study how is the charge distribution. So you took two parallel plates and you gave Q1 and Q2. So we are interested to find what is the charge distribution on the four faces. There are four faces, right? Left, right for each one. So we have to find the charge distribution. So this is how we start. So when you give charge Q1 and Q2, let the charge distribution be Q1. Let this charge distribution be Q2. Since the charge is conserved, this should be Q2 minus Q2. This should be Q1 minus Q1. Two variables, Q1 and Q2. Next thing, consider a Gaussian surface like this, passing through the metal. Now we can see inside the metal, the field is 0. Here the field is 0. And here we can clearly see the field is this way, whereas the area vector is perpendicular.
Then how did you consider the Gaussian surface?
I took a Gaussian surface passing through the metal, the two
ऐसे
edges.
किया, ऐसे.
3 dimensional में ऐसा होगा.
Okay.
Yeah, I'll draw it if you want. The plate's also three-dimensional now. Yes, sir. Understood? So this entire face is inside the metal. And E 0, so flux 0. And you have this perpendicular, so flux 0. Getting it? So in this thing, the flux in the Gaussian surface is 0. Therefore, the charge enclosed Q1 plus Q2 must be 0. Therefore, Q1 is equal to minus Q2. There. So we proved something again. If you take two parallel plates and keep them facing each other, they'll always have equal and opposite charges. Do anything you want. Is this making sense? So this we proved. Okay, so you have to remember this thing. Every time you won't be proving this. So now the new distribution would look something like this. Meaning this is Q, this will be minus Q, this will be Q1 minus Q, and this will be Q2 plus Q. There. So surfaces facing each other always have equal and opposite charges. Again, conducting surfaces. Huh? If it is not conducting, then E won't be 0, then the Gaussian surface flux won't be 0. Any doubts on this page, please ask me. This is your first argument, that opposite faces will have equal and opposite charge. And we proved it by using Gauss law. So we started with let it be Q1, Q2. By putting a Gauss law, we can clearly see the total flux is 0. Any doubts on this page? Clear. Next thing. We know the field due to an infinite sheet sigma by 2 epsilon and sigma by 2 epsilon. So now in our parallel plates, this is Q, this is minus Q, this is Q2 plus Q, and this is Q1 minus Q. So if you look at the field distributions, if I choose a point here, A is a point inside the conductor. The field at point A due to all charge distributions is 0. That's what we proved last class. Field inside a conductor is 0 due to all static charge distributions. That means this field, this field, this field, this field, all four will cancel out and they should give me 0. Make sense? So if you look at this, so it's like a sheet here. Q1 minus Q, I'll assume this is positive. This is also plus Q. I'll also assume plus Q is positive. This guy is minus Q. So I'll just put it as minus. This guy is Q2 plus Q. I will also assume it as positive. It doesn't matter. You can take positive or negative. Science will take care of it. Now, this guy, so we are talking about point A here. We'll give the field this way, which is sigma by 2 epsilon. Sigma is how much? Q1 minus Q by area, that is your sigma by 2 epsilon. This guy, I'll mark it green. This guy is also positive, so this guy will give field this way, which is Q by A by 2 epsilon. This I'll mark in black. This is a negative, so this will pull the field this way, which is Q by A by 2 epsilon. The sign indicates direction, so I'm just taking the magnitudes. This guy is plus, so this guy will push that way. So this is Q2 plus Q by A by 2 epsilon. So if you see, the red one and the black one are in the same direction, the green and the orange one are in the same direction. Can you see the field directions? Now all these four at point A should cancel out because it's a conductor. So now if you equate them, Q1 minus Q by 2A epsilon plus Q by 2A epsilon, the black one, should be equal to QA 2A epsilon, the green one. Actually, you can always see these two will always cancel. Q2 plus Q by 2A epsilon. Gone, gone. Q1 minus Q is Q2 plus Q. Therefore, Q is equal to Q1 minus Q2 by 2. Do have a look at the argument. So the thing is, these two guys will always cancel. That means this guy and this guy, the outermost charges should always fight it out. Do look at the proof. So your final answer is? If you give me two plates like this, Q1 and Q2, the charge distribution will be outside will be Q1 plus Q2 by 2. Inside will be Q1 minus Q2 by 2. The facing plate will have Q1 minus Q2 by 2. This is your distribution. Now you can do the same thing even better for n plates. I can do the same argument. And let's say now there are n plates. And let's say the charges are Q1, Q2, Q3, and Qn. Doesn't matter. The charge outside will be on the outermost surfaces will be taught always Q1 plus Q2 plus so on till Qn by 2. Listen, I will prove this very fast without doing anything. Listen carefully, this will help you a lot. First thing we proved, inside this is Q1 minus Q1, agreed? Equal and opposite. Matlab in dono total charges 0. Total charge 0. Total charge 0. Total charge 0. Agreed? Means all the charge in the center is 0. But for the full system, charge is conserved. And by symmetry, the total charge should be half here and half here. Because the charges on the inner faces will always cancel out because they're equal and opposite. The total charge of the system must be conserved. What's the total charge of the system? Q1 plus Q2 plus so on till Qn. That means the only place where charge can exist is the outermost surfaces. And by symmetry, both should be equal. So both will take half of each. Easy way to prove. You could have proved like this. So, but pehle we need to prove both are equal and opposite. So you can remember this. So outside charges will be sigma Qi by 2. And then from charge conservation, we can find here, this will be Q1 minus sigma Qi by 2 and so on. Now we can calculate everything by charge conservation. This is the result for n plates. Let me give an example in the next page. Do remember this thing. Total charge by 2 is the charges on the outer face. कुछ भी करो, it's always valid. Even if you earth it is valid, but earthing में कुछ और होता है, but it's still, the logic is still valid. All got this? Let me show an example.
So just one month.
हाँ निशा, clear so far? Arjun,
Yes,
clear
sir.
ना? Palaksh, Palaksh, clear so far? Udayan, be online, don't run away. I have to call you, invite you, only then you come. I don't know what you're doing exactly. And did you observe one thing? It didn't matter what's the distance between them. So example, let's say this guy is Q, minus 2Q, this is 3Q, this is 4Q. I want the charges on the each face. You guys tell me, what is the charge on the outermost surface? The charges on the outermost surface is total by 2. What is the total charge? 4Q, 3Q, 7Q, 8Q, 6Q. 3Q,
6Q.
3Q. But start kar lena. Now, since the plates, each one is isolated, total charge must be conserved. If this is 3Q, total is Q. यहाँ पे कितना होना चाहिए? Minus 2Q. You're getting it? Once you start from the outside, then it's over actually. Charge is conserved on each plate. If this is minus 2Q, this has to be plus 2Q. Because opposite faces will always be equal and opposite charge. If this is plus 2Q, total is minus 2Q, means this is minus 4Q. That means this is 4Q. This should be minus Q. This should be plus Q. Check. Easy. The one. So you start with the argument outside charge is total by 2, and then you start conserving from any one direction, you'll get the answer. You can remember this for n plates. Turn the page. Any doubts? Let's see a question. Let's say this is distance D and this is distance 2D. We have a switch here. This has plus Q, minus 2Q, and 3Q. Find the charge distribution before and after closing the switch. Switch open is easy. Closing is a different one now. So when it is open, total by 2, that is Q, 0, 0, minus 2Q, Q. Easy. And when you close the switch, what happens? Now things get messed up. Is the argument total by 2 is valid? Yes, that is still valid. Because again, same logic. When you close the switch, these charges will be always equal and opposite. So they will always cancel out. So here and here, charge has to be same. Why? Because the field here due to this and field here due to this should cancel out, no? So they should have equal magnitude. So total by 2. So that argument is still valid. But that insert charges, how do we find? Now that is goofed up. Because charge on each plate is not constant. Think for a minute, then I'll show you. Let's see. Listen carefully. We're going to prove it in general. Now you connected these two. Let this distance be d1. Let this distance be d2. It's a good result to remember. Now, let the charges be q1. This will be minus q1. Let this be q2. This will be minus q2. This much I know. They'll be equal and opposite. Now, try to understand here. So the field lines will go from here to here. Let's call this thing E1. Field lines will go from here to here. Let this be E2. So what is the field E1? E1 is Q1 by A, that is sigma, by 2 epsilon into 2 because both are there. So Q1 by 2A epsilon. Similarly, E2 is Q2 by A, that is sigma, charge per unit area, 2 epsilon, that is due to one sheet, but there are two sheets, plus and minus. So Q2 by A epsilon. So let me call this as plate 1, plate 2, plate 3. Now, if you see you're connecting plate 1 and 3, so you can say the potential difference between plate 2 minus plate 1, I'll just write 2 and 1, V2 minus V1 should be equal to V2 minus V3. Can I say this? Since 1 and 3 have same potential, V2 minus V1 should be equal to V2 minus V3. Right? Since 1 and 3 have same potential because they're connected by a wire. Therefore, but what is potential difference? Integral E1 dot dr integral minus E2 dot dr. Anyway, field is constant here, so this would be E1 d1 should be equal to E2 d2. Substitute the values. Q1 d1 by A epsilon is Q2 d2 by A epsilon. We get Q1 d1 is equal to Q2 d2. The charges will divide in the opposite ratio of distances. Pretty good result. Do mug it up. If you're connecting two plates, consecutive plates like this with a wire, this is the charge distribution always. We proved it for in general D1, D2. We can use it for anything now.
Sir, what if there are two or more plates in between them?
Then तो गया. Then तो एक एक करना पड़ेगा. We'll die.
Okay. So this is only valid when there is only one plate between them, no?
One blade between them.
And if there are any plates on the other side, तब भी नहीं होगा valid.
फर्क नहीं पड़ेगा ना. Now see, if there is a plate here, why will that affect this Q2 and Q2?
Okay. Okay.
You're getting it. You're getting the field between because of these two, na. And there's a metal here. Outside charges won't interfere.
Okay, got it.
All clear the result? Now using this result. Now, if you look at this question, so this was given plus Q, this was given minus 2Q, this is given plus 3Q. What's the charge outside? Total by 2. There's no discussion there. That would be Q, that would be Q. Then let this charge be Q1, let this charge be Q2. This would be minus Q1, this would be minus Q2. This distance is D and this distance is 2D. So Q1 plus Q2 should be minus 2Q because center plate ka charge is constant. And Q1, so basically this charge into this distance, it should be equal to this charge into this distance. And logically, if you think about it, right, if you have more charge, you have more field. If you have more field, E into D should be constant. Now, if you have more field, distance should be less. So Q1 into D should be equal to Q2 into D. So Q1 is 2Q2. Substitute here. So we get Q1 is minus 4Q by 3. And Q2 is minus 2Q by 3. That's your answer. Yeah, right, Yasha, you got it. All clear with this? Let's see one question. All clear? Turn in the page. Similar
Yes.
one, you guys try this now.
सर
Alright, God.
सर in our previous question तो like वही कर सकते हैं ना कि हम like we can assume some x charges going on that plate and again a point एक ले लें conductor के inside and उस पे हम like zero like equal कर दें
Field
like
is zero in the conductor, ना?
हाँ
कर सकते हो. Why proof है ना? Basically, we proved it in general, right? So why to prove it again and again? So we are using the result.
okay
Why कर रहे हैं actually? So these two are connected. These two are connected. This is D. This is D. And let's say this is 3D. This is plus Q. This is minus 2Q. This is 3Q. This is 4Q. Find the charge distributions. Now the formula we derived can be used for 3 plates like this. Try. Just give it a try and get some water and come. Any answers? It's 4q, q4q by 3. See? I don't remember the answers. So outside, total by 2. Total is 4q, 3q, 7, 8. So 3q, 3q. ना total वही है ना 4 3 7 8 8 minus 2 6 6 3q 3q doubt ही नहीं मतलब you can just dump it here without a doubt. If someone is still confused, look at how I will prove it. Let this be q1 minus q1, q2 minus q2, q3 minus q3. Total charge 0, total charge 0, total charge 0. So the outside the charges should be total charge. Second, if you take any point here, इस charge का field और इस charge का field equal होना चाहिए. That means both have same magnitude of charge. So the outermost charges should be same magnitude, and the total charge should be total charge by total charge. So there should be half of each. It doesn't matter. You put wire, you do any nonsense, it works. Only time it doesn't work is when you ground something because charge is not conserved. That we will see next. So 3q, 3q. Now the problem is I don't know what is the charge here. Why? Because 1 and 3 are connected. So we are going to use this statement q1 d1. So let this be x. If this is x, this will be minus x. If this is x, this is also x. Why? X into d should be equal to x into d, na? That formula is still valid, isn't it? q1 d1 is equal to q2 d2. Now, if this is x, this is minus x. Now, if this is y, we can clearly see minus x into d should be equal to y into 3d. Means y ka value is minus x by 3. If this is y, this is minus y. Got it? Now, charge on plate 1 and 3 is constant. Is 4q. So here 1 and 3 में क्या charges था? 3q minus x, y. These are the 4 charges on the plate. 3q minus x plus y is 4q. Though this is minus 2x and y is minus x by 3 is equal to q. X is equal to minus 3q by 7. Yeah, Akshika, you got it right. Is this clear, everyone? Because you have a distance d and d are equal, x into d, the product should be same. Here, minus x into d, y into 3d should be equal. q1 d1 is equal to q2 d2. That's what we proved here, that respect to charge into distance must be equal. So q1 d, q2 d2 should be equal. And then I'm saying charge on 1 plus plate 3, total should have been 4q. वो तो conserved है. From there I got x का value. So if you know the standard results, right? Outside is total by 2, q1 d1 is equal to q2 d2. Opposite places have equivalent opposite, you will get the questions. So you should know these 3 results. Faces will have equal and opposite charge. Outside is total by 2, q1 d1 is equal to q2 d2. Any doubts on this? Please ask me. This is a pretty good one. If you can get the hang of this, I think parallel plates, you are fine. Now let's see what happens if you earth a parallel plate. Any doubts on this?
Sir, I think I did some plus minus का उल्टा, but I'm getting some other answer.
क्या किया तूने? तेरा distribution कैसा था बताओ?
Q1 minus Q1, Q2 minus Q2, Q3
यहाँ पे क्या लिया? minus q1
नहीं plus Q.
plus q1 लिया, तो ये minus q1.
हाँ, and Q2.
ये कितना लिया?
Q2
q2 लिया.
हाँ.
तो q2 also लिखो minus q1. Because minus q1 into d, q2 into d should be equal. Therefore, q2 is minus q1.
Sir, 1 minute, sir. If we leave it as Q2 only, I'm getting some weird result. Please write like that only.
Then you have to apply the
Q2
two
छोड़ के.
things ना रे formula. See, Q2 छोड़ के मतलब weird result कैसा आएगा? You have to
Then
substitute
I
तो
just
करना
use
पड़ेगा
charge
ना.
conservation. और
नहीं है, then
उससे
you'll be stuck
I
with two
was,
variables. You'll be stuck with two variables. Solve नहीं होगा.
हाँ सर वो ठीक है, but I was still कुछ भी, I was getting something weird like Q1 minus. I'll just, I think, send it to you.
देख लो, देखते हैं. But this is clear ना? Yeah.
हाँ सर, yes sir.
आया ना? वो
हाँ
Q1 Q2 का भी रिलेशन निकालना पड़ेगा आपको. मैंने डायरेक्टली XX लिख लिया यहाँ पे.
हाँ ठीक.
Getting it? I have taken it directly X and X because I know the distance are equal.
Hmm.
Next thing, what happens if you earth a parallel plate? Now here we have a different argument in terms of energy. Now understand one thing. Whenever you earth a system or anything, every system right in the universe will try to always achieve a state of least energy. So if you give a chance for a system to change its energy, it will do its best to minimize its energy. So if you have parallel plates like this, we'll have charge Q, and here we'll have, let's say, Q1 minus Q1. This is Q2 minus Q2. This is Q3 minus Q3. So we know the facing plates will always have equal and opposite charge. So in the diagram, we can see in parallel plates, facing surfaces have equal and opposite charge. Therefore, their potential energy is negative. K Q1 Q2 by R, right? So something like that. They have a negative potential energy. But if you look at the charges on the outer system, they both are equal and positive or negative, whatever it is, are repulsive, meaning they'll always create a positive energy on the system. Now you tell me, if this is your system and if I give you a chance, जो charge चाहिए ले लो, meaning whatever charge you want from the earth, you can take it, right? You can take whatever charge you want. Minimize the energy, meaning make the energy as negative as possible. So the one charges whom you want to eliminate are what? This Q and this Q, right? Technically, if I can make this Q and minus Q, that would be even great because you'll get more negative energy. But problem ये है, those two charges are always equal. So energy is KQ square. What is the minimum value of this function? 0. You getting it? So when any plate is grounded, you need to see that argument there. You're giving the system a free hand and saying, you take whatever charge you want from the earth, no issue. Just make sure your energy is minimum. When plate is grounded, the system minimizes the energy. That is the whole purpose of any system, to become more stable. To become more stable, you need to lose energy. You need to have minimum energy possible. And if you see here, the inside pairs are positive, negative. They're actually happy because you're getting more negative charge. They're more stable. Negative charge systems are stable, isn't it? They're bounded pairs. Minimize the energy by eliminating. There's only one problem here, the outside two charges. By eliminating the outermost charges. So it's a pretty straightforward result. Therefore, whenever you ground even one plate, outside charges are 0. It doesn't matter. You ground any one of the plate, any one of the plate or multiple plates. So this is one new extra thing. So whatever I taught you till now, that all that is valid, this is additional. When any plate is grounded, charges on the outermost surface are always 0. And that argument total by 2, you will see that also is still valid. We will see how. This is the reasoning. We can explain this in terms of energy. Connecting to the earth means that when you connect to the earth, you're saying, boss, you can take any charge you want. Just make sure you get a minimum energy possible. The only issue here with creating is those two positive charges. Clear with this? Let me show an example how it works. Look at the example.
The charge on outermost मतलब उस particular plate का कि जो पूरा
सब
system
दोनों
है
दोनों
उसका?
दोनों
Oh,
दोनों को eliminate करना पड़ेगा. See, the moment you make this zero, this guy will automatically become zero
हाँ.
because they always have to be equal.
Hmm.
So look at this thing. If I ground the leftmost plate, look at this example. You'll get the hang of it. It's quite straightforward. So if I ground this plate, first thing 0 0 discussion nahi hai. 1. Second thing, can I conserve charge on this plate? You can't conserve
No.
charge on this plate because it is grounded. So start from the right hand side. So this has to be 3q now. So be careful here. Charge is not conserved on this plate. Whichever plate you ground, you can't conserve the charge. Then this has to be minus 3q. The total is minus 3q, so this has to be plus q. This has to be minus q. What is the total charge? 0 0 0. So what is the outside charge? Total charge by 2 0. That thing is still valid. The total charge on the outermost plates is total charge by 2. The problem is this: because you're grounding the plate, you don't know what is the total charge anymore. I hope you're getting the thing there. That statement, total charge by 2, is still valid. The problem is, I don't know the total charge because you grounded them. Let me take one more example. See, what if I ground the middle plate? So if I ground the middle plate, 0 0. So this guy is plus q, this guy is plus 3q, this guy is minus 3q, and this guy is minus q. And you will notice something. The total charge, right? 4q charge goes into the earth. Yeah, 4q नहीं, 3q q.
So 2q goes into the earth, no?
Where कुछ तो गड़बड़ किया मैंने, रुको. 0 3q minus 3q, that is minus 2q, so this should be q. This is minus q. Total charge is 2q, na? Sorry. So 2q flows away. So did you observe one thing? All the charge flows into the earth. What is the total charge on the system? 2q. देखो ना, initially how much charge was there on the plate? Plus q. Now how much you have? Minus q means how much charge flowed away? 2q, right? This is what is happening. Total charge is always becoming 0. The moment you ground one plate, the total charge of the system becomes 0. Look at the rightmost plate. If I ground the rightmost plate, can someone tell me the answer? Start from 0 0. You can't start from right now because right is not conserved. Left से start करना पड़ेगा. Plus q, minus q, minus q, plus q. If you observe, again 2q flows into the ground. You connect any plate, 2q flows into the ground. Everything you learned is still valid. Total charge by 2 is still valid. Q1 D1 is equal to Q2 D2 is still valid. Opposite faces of equal and opposite charge is still valid. The fourth new thing you learned is when you ground something, outside charges become 0. Have a look at this. Saina, clear with this? Battery got over. Let's see. Let's do one problem. If you got the problem, your parallel plates are clear. Turn in the page. Last one for the day. Now I'm grounding the third plate. Same question which we did. Plus Q, minus 2Q, 3Q, 4Q. This distance is D. This distance is also D. This distance is 3D. Now there's a ground, there is this thing. Like this is the good version of grounding, connecting everything you're doing. Finish off, last one. What are the outside charges? 0.
0, 0.
That's it. You ground something, discussion close, outside is 0. Look at my charge distributions. Just keep it in one variable. Now don't create too many variables. Now, can I conserve charge on 1 and 3? You can't. That is a catch. So you can't do charge 1 and 3 conservation. You can do 2 and 4. Charge on 1 and 3 is not conserved. Charge on 2 and 4 is 2Q. That is x and x plus x by 3 is 2Q. X is equal to 6Q by 7. 12Q by 7, okay? Did I go for?
No, sir. I did 4Q total charge. गलती से sir. Ignore.
ठीक है. Easy? Correct, na? Perfect. Right, yeah. Easy now? Making sense, parallel plates. So those are the 4 things you should know. Total by 2. Q1 D1 is Q2 D2. Opposite faces will always be equal to opposite charge. If you ground something, outside charges become 0. You know, those 4 points will be able to handle most of the parallel plates. Clear? So we have done almost 21 problems. So make sure to do this thing. So we're almost done with the Gauss laws. After this, there's something called a mirror image method, so which I'll teach you in next class. So with that, we'll wrap up for that day. So any doubts in today's class? Anything else you can ask me, or else you're free to leave. So I'll see you guys again next Wednesday. We'll continue from here.